All right, on number 4, my guidance is to always make a table. And so let's start out with a table. I know what the x-axis is going to be. It's going to be years because they told me so here. So n is always my x. My pn is my y. Pn is, in this case, they tell you it's defined as the amount of money in the savings account after n years. I just put amount of money in the account. That's actually not good form. You should write amount of money in the account after n years because there's 2 letters here and you need to give a legend to your users of what those 2 columns are. And then start filling in the table. I have some information here. First of all, this 125 that's in red for me, which will not be in red for you, is the initial condition. It's the initial amount that you start with to before you start to accrue your interest. So the 125 goes there. Then what I'm going to do is actually just calculate what I need in the first year. And that's actually fairly easy compared to coming up with a DDS. In year 1, I'm going to have the 125 I started out with, and then I'm going to get interest. And that's 6% interest annually. So I'm going to accrue that interest. And now I'm going to put $35 every month in the account. But I'm looking at the end of the month, so I have to multiply that by 12. Now, I'm making an assumption here that they are not accruing the interest of the amount that I'm putting in monthly first. So otherwise, that would have changed this thing that I point to, the gray term. And so I know that's the assumption that's wanted because I can see the answer here. You don't see the answer on your version, but I could see the answer here. So I understand that inherent to this, the modeler who put this together decided that. I could have gone the other way. You can decide whatever you want, as Colonel Watts would say, ahead of time. But the assumption here is that the amount I put is not going to be used in this accretion of interest. So now I have year 1 done. How do you get your DDS? You replace all the P0s that you used with Pn minus 1, and you replace year 1 by Pn. And voila, I have my DDS. So that's what goes up here. You can clean it up a little bit by gathering your like terms. I have 1 plus 0.06. There's a 1 here in front of the Pn minus 1. I gather that together and I get 1.06 and put that here. So notice I cleaned it up so it looks as in the shell form we always use for fake problems. Pn is equal to A Pn minus 1 plus D. The next thing they ask is to classify the long-term behavior. It's not clear whether they want me to have the limit or whether they want me to say it's divergent. So I did peek at the answer. They want divergent. How do I find that out? Well, I have a table that we use in our class. The A is bigger than 1 because A is 1.06. And so I go over here and I have a column which says long-term behavior. And if you look at that cell, it's going to plus or minus infinity, which is divergent. That's what you put here. And then I'm asked about P1 and P4. I put this into Excel. You need to do this, be able to do this. We have our classes doing this in under 1 minute and 4 seconds, the Freiberg constant. But I already had it cooked like Rachel Ray. I had the ingredients there. Who wouldn't like to cook a meal with all the stuff half done already? So I already have it done. My initial condition went up here, and then I have, what was my initial condition, by the way? 125, so it's correct. And now that I have the initial condition in here, I put in my A, I put in my D, my P star is automatically calculated, and because I made it so, notice it's the formula D over 1 minus A. And then just to remind you, the formula I'm scrolling down is $C$2 times B2 plus D$2. B2 is my P0, this is my A, and this is my D. Scroll it down, and I highlight 1 and 4. I peel those things out and put them into this section that asks for P1 and P4, which I didn't fill in. You'll have different numbers for yourself.